In this video, we're going to have a look at how to use the binomial theorem to figure out the general term of a binomial, and then how to use that general term to find a particular term. So on the right here, I've got the binomial theorem. This is given to you on your formula list. When you expand a binomial, you can write it to in this form here. N choose r, a to the n minus r, b to the r. We would use the summation symbol if we were asked to simplify, but in this example, we are just asked for the summation. So what we're going to do is we're going to take our example and we're going to slot it into the formula. The formula is a plus b to the n is equal to n choose r, a to the n minus r, b to the r, where n is the power of the binomial. So if we have a look at our problem, x squared plus 1 over x to the power 10. Hopefully you can see that the power is 10, therefore n is 10. We do not know r. A is the first term, so we've got x squared to the 10 minus r, and then we've got 1 over x to the power of r. So this has now slotted this into our formula. Obviously there's r's that we don't know, and that's what we're eventually going to figure out. What we're going to do is we're going to tidy this up. We're going to get all the x's together and all the numbers together. So we're going to have 10 choose r, and hopefully spot here that we have a power to a power. When we've got a power to a power, we can multiply those. That's going to give us x to the 20 minus 2r. This person here we might want to make look a bit nicer first before we apply the power. This is the same as x to the minus 1, and that's to the power of r. So we can keep going, we can keep simplifying here. So we're going to have 10 choose r, x to the 20 minus 2r, x to the minus r. Once again, we've got a power times a power. So we multiply a power of a power. So we multiply them. What we've got now though is we've got a situation where we're multiplying. When we're multiplying, we're going to add the powers. So we're going to do this plus this. And that's going to get us down to a stage where we've got 10 choose r, x to the 20 minus 3r. This is our general term. Okay, the general term where we've got x's and numbers. Here we've not actually got any numbers, we've just got x's. So hence or otherwise obtain the term in x to the power of 14. Okay, I'll do this in red. So we want the term in x to the power of 14. Well, if we have a look at our x term of our general term, 20 minus 3r, we want this to equal 14 to match this here. Therefore, the expression 20 minus 3r, we want it to be equal to 14. We can do some solving here, and we should find that 3r is going to give us 6, and that is going to give us a value of r equals 2. So in order for us to find the coefficient, hence or otherwise obtain the term in x to the 14, what we're going to do is we're going to take our general term, 10 choose r, x to the 20 minus 3r, and we're going to substitute r equals 2 into that. So to find the term in x to the 14, it's going to become 10 choose 2, and that's going to become x to the 20 minus 3 times 2. 10 choose 2 times x to the power 14. So this is the term in x to the power 14 that we need to calculate. So we can just do this at the side. 10 choose 2. We can do 10 factorial over 2 factorial, 8 factorial. We can do some simplification if we rewrite our numerator. 10 times 9 times 8 factorial over 2 factorial, 8 factorial. These 8 factorials can simplify. We're going to be left with 90 over 2 times 1, which is 45. So therefore, the term that we're looking for is 45 x to the 14. So answer here, the coefficient is 45. 5. Like so. Okay, so we take our binomial, we put it into the form here, we simplify letters, we simplify numbers, we get it to a stage where we've just got the x's together and the numbers together, and then we find the term that we're looking for. That was example 1. Example 2. Find and simplify the general term in the expansion 2x minus 1 over x squared to the power of 9, hence or otherwise obtain the term independent of x. We'll come back to that in a little moment. It's talking about the general term. Generally, to figure out the general term, we've got a plus b to the power n is n choose r, a to the n minus r, b to the r. So if we have a look at our problem, 2x minus 1 over x squared to the power of 9, hopefully you can see that n is 9 in our example. We're going to have 2x to the 9 minus r, and b is going to be minus 1 over x squared to the r. So this one's a wee bit more complicated compared to the first one. What we want to do is we want to get all the x's together, all the numbers together. So what we're going to do is we're going to apply the powers of powers. So if we apply this to both, this will become, so it's 2 to that power, 2 to the power of 9 minus r, x to the power 9 minus r. Remember, the power applies to both. And I can rewrite this as minus x to the minus 2, all to the power of r. I'm going to have 9 choose r, 2 to the n minus r, x to the n minus r, and then we're going to have minus x, I'll rub that out, sorry. We can rewrite this because we want to separate numbers and letters, so we can rewrite this as minus 1 to the r, x to the minus 2r. Okay, so what I did there is minus x to the minus 2 to the r. That is the same as minus 1x to the minus 2 to the power of r. And if we apply that power of r to both, we're going to have minus 1 to the r, x to the minus 2r. Okay, so we want to get the letters together, so we're going to get the x's together here. So we're multiplying, so we're going to add these powers. That's going to give us 9 choose r, 2 to the 9 minus r, minus 1 to the r, and then we're going to have x to the 9 minus 3r. This is our general term. We have separated our numbers from our variables. Okay? So the question says, hence or otherwise obtain the term independent of x. So independent of x, I'll go a different colour here. Independent of x would imply that the term is a constant, which would imply that we've got an x to the power of 0 involved here. So we're going to look at our x term. Okay, so we want x to the power of 0, because if it's the power of 0, it's not going to depend on x. So we want this power to be 0. So what we're going to do is we're going to figure out what r is going to be. We're going to 3r equals 9, leading to r equals 3. We've now found out the value of r, and now we can slot this in to our big general term formula. So it's 9 choose r, so it's 9 choose 3, 2 to the power of 9 minus 3, minus 1 cubed, x to the 9 minus 3 times 3. We can simplify. 9 choose 3 times 2 to the power 6 times minus 1 cubed times x to the power 0. So the term that's independent of x is going to be this big number here. We can work this out. we can do some maths. It is going to come out to be quite a big number here. It's going to be negative as well. When we work through this, could come up in a non-calculator or in a calculator paper. But if we work through, we should find that we can do some maths here. Do it at the side. 9 choose 3 is 9 factorial over 3 factorial 6 factorial. We can rewrite 9 times 8 times 7 times 6 factorial over 3 factorial 6 factorial. These 6 factorials can simplify. So we're going to have 9 times 8 times 7 over 3 times 2 times 1. So we're going to have 9 times 8 times 7 all over 6, whatever that number is. Let's just type this into a calculator. 9 times 8 times 7 divided by 6, which is 84. So 9 choose 3 is 84. 2 to the power of 6 is 64. So we're doing 84 times 64 times negative 1. So 84 times 64 times negative 1 is minus 5,376 x to the power of 0. That is the term that is independent of x. Okay, so we just worked through two examples there where we had to find the general term, and then we had to use that general term to figure out the value of r, which would allow us to work out the coefficient of the value that we were looking for. In the first example, we got a positive answer. In the second example, we got a negative answer. Sometimes you get some weird answers coming out as well. Thank you very much.